Our case study topic is a learning framework on high-performance transactions in database. Introduction. Database transactions provide a safe and predictable programming model to deal with concurrent changes to the data. Traditional relational databases like SQL Server allow you to write the business logic using stated procedures and triggers, send it to the servers for execution directly within the database engine. With traditional relational database, you are required to deal with two different programming languages. Application programming language such as JavaScript, Python, C#, Java, etc. and the traditional programming language such as SQL that is natively executed by the database. The database engine in Azure Cosmos DB supports full asset atomicity, consistency, isolation, durability, compliant transactions with snapshot isolation. All the database operations within the scope of container logic partition are transactionally executed within the database engine that is hosted by the replication of partition. These operations include both updating one or more items within the logical partition and read operations. Literature survey. Transaction model is composed of 6 different components: source, sink, transaction manager, resource manager, recovery manager, and concurrency control manager. The source is responsible for generating the workload such as file access, page access, updating a file for a site. Once the source generates the workload, transaction manager is used to handle the execution of the transaction. Concurrency control manager is used to control concurrency with request. Concurrency control algorithm. The resource manager takes care of various resource parameters such as CPU, file, disk for read or write operations. Problem analysis. When multiple transactions execute concurrently in an uncontrolled or unrestricted manner, then it might lead to several problems. These problems are commonly referred to as concurrency problems in database environment. The 5 concurrency problems that can occur in the database are temporary update problem, incorrect summary problem, loss update problem, unrepeatable read problem, phantom read problem.
Solution. Database system, like any other computer system, are subject to failure, but the data stored in must be available when required. When a database fails, it must possess a faculties for fact recovery. It must be have a atomicity, either transactions are completed successfully and committed, the effect recorded permanently. Is the database the transaction should have the effect on the database. There are both autonomic and non-autonomic ways are both booking for every and recovery and failure situations. The technique to recover the lost due to the system crash. Transaction arises various catastrophic failure and incorrect and command execution, etc. Are database recovery techniques so prevent data loss. Recovery techniques based on deferred data and immediate update or backing update can be used. Solution. Some of the solutions are as follows. Full database backup. In this full database backup, including data and database meta information will be restored. The whole database, including full text categories, are backed in the perfinite time series. A different backup. It stored only the data changed to have occurred since the last full database backup. When some data has changed many times since last full database backup. Conclusion. A transaction in context of database is a logical unit that is independently executed for data retrieval or updates. A database transaction is a series of operations performed within a database management system against a database such that once completed, the data is left in a reliable and consistent state. If any step of the transaction fails, then all steps are reversed so that data integrity can be maintained. Okay.